diba, since yung length daw ng curve ay 130 meters, so, dahil symmetrical naman siya, dinivide ko lang sa 2, so this part is 65 meter and this part is 65 meter too. And then, our first grade would be negative, kaya siya sag. And then the second grade is positive, which is positive 1.5. And then for the first na hinihingi, which is the highest or lowest point of the curve, we'll use the formula S sub 1 over G sub 1 is equal to length over G sub 1 plus G sub 2. Dahil meron naman tayo ng value ng G sub 1, ng length, ng G sub 2. So, makuha na natin yung S sub 1. So, input lang 2.1% times 130 over 2.1% plus 1.5%. So, overall, pag input mo sa calculator, ang lalabas ay 75.833 meters. That's for our first problem. Next, for the second hihingi, we'll look for the station of the lowest point of the curve. Diba meron na tayong S sub 1? So, hahanap yung lowest point niya, ito. Okay? So, to get that, we'll first look for this distance. Kasi diba, 75.833 mula dito yon sa PC, pag ganon. Pero dahil 65 lang to, meaning, may susobra. Ito yung distance na yon. So, 75.833 minus 65 meters, ito, equals 10.833 meters. And then, i-add na lang natin yung value na yon sa value ng stationing or ng station ng PI. So, stationing of A, which is the lowest point, is equal to station of PI plus T, or this distance. So, 11 plus 488 plus 10.833 meters. So, the station of the lowest point is 11 plus 498.833. That's simple. Kasi natin naman na ang length ng curve ay 140 meters. So, again, dinivide ko lang siya into 2. We have this part of 70 and the other one 70 meters. A total of 140 if you're going to add them. And then, nilagay ko na yung value ng G sub 1, which is negative 2.6%, and the G sub 2, which is 1.2%. Again, it is another sag curve because our first grade is a negative 1. Okay? And then, this is the PI, whose elevation is 4.50 meter, and then its station is 6 plus 300 kilometers. Ayan. So, for the first number, sabi, we need to find the lowest or the highest point of the curve. Again, just, the formula for that is the same as what we used at the first problem. We have the S1 over G1 is equal to L over G1 plus G2. Okay? So, S1, we'll just have to multiply these to the right hand side of the equation. So, matitira si S1 sa left hand side. And then, we'll have G sub 1 times length over G sub 1 plus G sub 2. And then, input lang natin yung data. And then, we'll have 95 and 789 meters. Naman, sabi kasi doon, determine the vertical distance between the point of intersection and the curve. This is the point of intersection. And this is the curve. So, if we're going to look for the distance, it is just simply the h. Okay? And we already have the formula of how to get the h. It is 1/8 of the length times the G sub 1 plus G sub 2. Eh, meron naman tayong lahat ng value ng L, meron tayong value nito at nito. So, we could simply input all we have and then put it on the calculator and then lalabas ang value na 0.665 meters. problem, a grade line BK having a slope of 5% intersect another grade KD having a slope of negative 4.33% at K. The elevation of points BKD are 85 meters, 90 meters, and 87.01 meters, respectively. First, determine the elevation of PC, and then second, determine the elevation of the summit of the 100-meter parabolic vertical curve to connect the grade line. So first, let's determine the distance between the BK and the distance between KB. You just have to subtract the elevation point of BK to 100 and then divide it by the grade, and you'll have 300 meters. And then we'll divide the 300 meters into 2. And then the same goes for the distance K and D, which is 100 minus 87.01 divided by the negative 4.3%. We'll disregard the negative sign, so we'll just have the positive 0.043, and that will be equal to 300 meters, and then we'll do it, we'll divide it again into 2. So we'll have this is 150, 150, 150, 150. And then, since the first grade is positive, so we'll have the summit curve. And then, diretso na tayo na kunin ang elevation ng PC. The elevation of PC is just the elevation of B, which is this, plus the distance from here up to there. So, as you can see on the picture or the diagram or the illustration, it's just 150 times the grade, which is 5%. So, 85 plus 7.5 is equal to 92.5. So, the elevation of PC is 92.5. So, its elevation is 92.5. Next, we are asked to look for the elevation of the summit. First, we need to look for the distance from PC to summit. Summit is the highest point of the curve. So, just use the formula S of 1 over G sub 1 is equal to L over G sub 1 plus G sub 2. So, that's simply S1 over 0.05 equals 300 over 0.093. And we'll put it on the calculator, and you'll have 161.290 meters. That's the distance of the summit from the PC. So, from here, it's 161. So, sobra siya ng onti kasi 152. So, for the elevation of the summit, we just need to add the elevation of PC plus 1/2 of the S1 times the grade, 0.05. So, input nyo lang po yun, and then you'll have the elevation of summit equivalent to 92.532 meters. Thank you.
So guys, we have an unsymmetrical problems. A forward tangent of 6% was designed to intercept a back tangent of negative 2.5% at a proposed underpass so as to maintain a minimum clearance allowed under a bridge which crosses perpendicular to the underpass. A 220-meter curve lies on the side of the back tangent, while a 150-meter curve lies on the side of the forward tangent. The stationing and the elevation of the grade intersection is 5,535 and 100 meter, respectively. And the center line of the bridge falls at 5,585. The elevation of the underside of the bridge falls 115 meter. Determine the minimum clearance of the bridge if it has a width of 10 meter. Gawa na tayong structure. Sabi sa problem, meron tayong back tangent na negative 2.5% at meron tayong forward tangent na positive 6%. So yun, gawa na tayo ng curve. So, dito yung PVC, PVT, PVI. So yun, meron tayong length. Tapos yung length natin sa back tangent is 220 meter and the forward tangent is 150 meter. So, meron rin tayong stationing na 5,535. Meron rin tayong elevation na 100 meter. So, yung station natin is 5,535. So, dito siya sa may bandang left, sa may forward tangent banda. So, gawa tayo ng bridge sa taas. Yun. Tapos yung center line natin is 5,585. Tapos yun guys, yung length ng bridge natin is 5 meter. So, equal siya sa 10 meter. Tapos yung elevation ng bridge natin is 115 meter. So, meron tayong tatlong clearance. Yung sa may bandang left, clearance sa center line, clearance sa may right, clearance. So, yung minimum clearance is yung sa bandang right kasi yun yung pinaka maikli. So, yun yung kukuhain natin. And then, kunin natin dito yung angle ng A. So, yung A, kuha tayong triangle dito. A. Then, so, 50 plus 5 meter. So, magiging 55 meter and grade 2. So, yung A daw natin is merong 6% times 55. So, yung A natin is 3.3. Kukuha natin yung Y1. Pero, kunin muna natin yung X1. So, X1 is equals to 150 minus 55. So, X1 is equals to 95 meter. So, Y1 is over X1 squared. Then equals to H over length 2 squared. So, H is equals to L1 L2 multiplied by first grade and second grade over 2 multiplied by L1 plus L2. So H is equals to 220, which is L1, and multiplied by 150, which is L2, and multiplied by 2.5%, which is grade 1, plus 6%, which is grade 2. So over 2 multiplied by 220, which is L1, and plus 150, which is L2. So equals H is equals to 3.791 meter. So Y1 is equals to 95 squared multiplied by 3.791 over 150 squared. So Y1 is equals to 1.521 meter. So to get the minimum clearance is equal to 115 minus 100, then minus to 3.3, then minus to 1.521, and then we have the minimum clearance is equal to 10.179 meter. So that is the answer on our problem number 1. So in unsymmetrical parabolic curve, we have problem number 2. So a forward tangent having a slope of negative 4% intersects the back tangent with a slope of 6.3% at point V at station 4,350 with elevation of 250 meter. The curve will pass through point A with elevation of 240 meter at station 4,325. The length of the curve is 60 meter on the side of the back tangent. So, letter A, determine the length of the curve on the side of the forward tangent. Letter B, determine the stationing of the highest point. Letter C, determine the elevation of the highest point. So, letter A, we're looking for L2. So first we need to get the H. So H is equals to L1 multiplied by L2 multiplied by G1 plus G2 over 2 multiplied by L1 plus L2. So Y1 over x1 squared equals to h over L1 squared. So side A, the 25 meter G1. So A is equals to 25 multiplied by 6.3%, then equal to 1.575 meter. So elevation of A is equal to 250 minus 1.575 is equal to 248.425. So y1 is equal to 248.425 minus 240 is equal to 8.425 meter. Then x1 is equal to 60 minus 25, then equal to 35. Then h is equal to 60 squared multiplied by 8.425 over 35 squared. Then you get the h. So h is equal to 24.759. Then 24.759 is equal to 60 multiplied by L2 multiplied by 6.3% plus 4% over 2 multiplied by 60 plus L2. So shift solve, then L2 is equal to 66.05 meter. So in letter B, we are determining the stationing of the highest point. So letter B, h is equal to 24.759 from here. Then G1 multiplied by L1 over 2 is equal to 1.89 meter. So since h is greater than G1 multiplied by L1 over 2, so our solution is S1 is equal to G1 multiplied by L1 squared over 2 multiplied by h. So S is equal to 6.3% multiplied by 60 squared over 2 multiplied by 24.759. So we get the S. So S is equal to 45.802. Letter C, we need to determine the elevation of the highest point. So C, we have a side B and a 20.248 meter. So 20.248 meter from L2 minus S. So 66.05 minus 45.802 is equals to 20.248 meter. Then B is equal to 20.248 meter multiplied by 4%. So the B is equal to 0.810 meter. Then the elevation of B is equal to 250 minus the B, so which is 0.810. Then B is equal to 249.19 meter. Then y2 is equal to x. In unsymmetrical problem, we have problem number 3. So a forward tangent having a slope of 6% intersects the back tangent with a slope of 7% at point B at station 4325 with elevation of 230 meter. The curve will pass through point A with elevation of 220 meter at station 4300. The length of the curve is 50 meter on the side of the back tangent. So letter A, we need to determine the length of the curve on the side of the forward tangent. Letter B, we need to determine the stationing of the highest point. Letter C, we need to determine the elevation of the highest point. So in back tangent, we have 7%, and in the forward tangent we have 6%. So in the length of our, we have 50 meter, and the missing is L2. Then we have the stationing of 4,300. Then it has elevation of 220 meter. Then we also have a stationing of 4,325 and its elevation is 230 meter. In A, we are determining the length of the curve on the side of the forward tangent. So letter A, H is equal to L1, L2 multiplied by G1 plus G2 over 2 multiplied by L1 plus L2. So Y1 over X1 squared equals H over L1 squared. So we have a side of A and we have a 25 meter and a G1. So A is equal to 25 multiplied by 7% and equal to 1.75 meter. So elevation of A is equal to 230 minus 1.75, so equal to 228.25. So Y1 is equal to 228.25 minus 220 is equal to 8.25 meter. So X1 is equal to 50 minus 25 is equal to 25. So H is equal to 50 squared multiplied by 8.25 over 25 squared. So the answer is 33. So we have H is 33. So 33 is equal to 50 multiplied by L2, then 7% plus 6%, then over 2 multiplied by 50 plus L2. So L2 is equal to 55.462 meter. So in letter B, we need to determine the stationing of the highest point. So H is equals to 33. Then G1 multiplied by L1 over 2. So the answer is 1.75 meter. So since H is greater than G1 multiplied by L1 over 2, so we have this solution. So S is equal to G1 multiplied by L1 squared, then over 2 multiplied by H. So S is equal to 7% multiplied by 50 squared over 2 multiplied by 33. So the answer is 2.652. So this is the S. So in letter C, we need to determine the elevation of the highest point. So we have a side B and 52.81 meter, then G2, then B is equal to 52.81 multiplied by 6%. So we have a B that 3.169, then elevation of B is equal to 230 minus 3.169, which is B. Then B is equal to 226.831. So Y2 over X2 squared then equal to H over L2 squared. So Y2 is equal to 2.652 squared multiplied by 33 over 55.462 squared. Then Y2 is equal to 0.075. So elevation of a highest point is equal to 226.831 is minus 0.075. So we have the elevation of a highest point, which is equal to 223.662 meter.